יש שגיל צריך ככה ללכת לעבודה כל יום.
נכון, מדבר עם הבוס שלו, מדבר עם יומה.
Good evening, everybody. Happy that you could join us this evening for a talk about flood adaptation. So we have a very distinguished panel with us today, and I'll start by introducing the topic and our panel members. So, first of all, why talk about floods in a climate conference? Because we are seeing increased flood events. This is a combined action of both the climate change, which changes the intensity of rains. As the climate becomes hotter, the clouds become denser with more water content, and therefore heavier rains are possible. And at the same time, we have urbanization, and the soil, we have less and less soil and more asphalt and roads. So we see it worldwide, and of course there are a lot of examples if you just think about the last year of flood events all over the world. Now, when we talk about adaptation to such a situation, one possible adaptation strategy is to design and build to reduce flood risk. This is a slide out of WMO, and there will be more detail in the next during this presentation. Integrated flood risk management. We will talk about it. The other possible adaptation strategy is to improve the preparedness and the emergency response. So we will go through this cycle you see here, which is what is used in order to have a good early warning system, and not only collection of data, modeling, early warning, dissemination, and then the decision support and the action to be made. So we'll talk about this as well. But maybe the best adaptation strategy is to collaborate. And first of all, one needs to collaborate within the country, and then one should also try to collaborate between the countries and the neighboring countries, or the community, international community as a whole. And this will be the focus of our talk this evening. As you see, there's a lot of logos on the screen, and actually each of us here comes from a different organization, a different ministry, and even from outside of the country, and this is the kind of collaboration that is needed in order to tackle this issue, this complex issue, properly. So we have here Gedi, who represents here the emergency authorities. Gedi is the head of reference scenarios in the National Emergency Management Authority of Israel. We have here Itai, who is the representative of the local authorities, is the head of the Dead Sea Drainage Authority and the chair of all drainage authorities of Israel. He will explain to you a little bit what is a drainage authority, which is maybe not a common concept. There is also a representative of the meteorological service. This is me. Nir Stav, and I'm the head of the Israeli Meteorological Service. We have with us Yael from the Hydrological Service in the Water Authority of Israel, and she's the head of surface water hydrology. We have with us the academia, which always must be a part of any adaptation effort, and we are always doing adaptation based on science, and especially, as we said, models, data. This calls for support of academy. So we have with us Professor Efrat Morin from the Hebrew University in Jerusalem. As I said, we need not only to think about what happens during an emergency, but rather also to build and design so that we will be less vulnerable in a case of a flood. And this angle will be discussed by Ben Yacovi from the Ministry of Agriculture, Land Preservation Department. And we have with us also the head of hydrology in the World Meteorological Organization, WMO, Stefan, and now I'll probably do the family name wrong. Unbruch? Uhlenbrock, sorry. We just met, so I know. But like an Israeli, I know only the first name, the family name, who cares? So, each of us will try to speak for a short time, but to give the angle of the different entity. And one of the things that we will try to do is to tell you about this mutual dance, how we collaborated to work together, because I think this is maybe the essence. So, Gedi, this is now your talk.
Good evening. My name is Gedi Abadi, and I'm the director of different scenario at the NEMA, National Emergency, in the Ministry of Defense. Today I will introduce you a national flood reference scenario. In the first, we speak about the challenge. First of all, we have a few challenges to deal with this problem. The first one, the challenge is dealing with climate change, challenge state, institution, and system. While it also carries potential damage to infrastructure and impact of our daily life. This is the first one. The second challenge deals with a case of eruptive emergency. In NEMA, we deal with eruptive emergency. This is our case business. And when I speak about that, we have the strait map, defined 4 climate strait, consider a national level risk in case of eruptive emergency. We must understand that those straits require national reference scenario. This is the numbers 2. The third challenge is to ensure coordination and guidance. Why need this coordination and guidance? We needed the coordination guidance to ensure a national vision. We must see about the vision, to put the national inside and to understand what is the next step that we want to go there. This is the third. The last challenge is to build program in order to face those challenges. We need to have a national reference scenario for flood, which is the handstone for planning. Why it's important? Because the handstone, the national reference scenario regard floods is the headstone to facing this challenge. Later I will explain you and show you why the reference scenario is stoned and why we must understand, because we start a plan, the reference scenario must be the beginning of this plan. And now I show you why. National produce in preparedness those threats. Okay. We have 5 stages that I will talk about them. One stage is reference scenario. What is reference scenario? You can see what is right down. But I give you reference scenario is a story that tells us the duration and scope of a problem. The reference scenario gives us basic information for preparedness and build a working plan. This is the working plan, all of which must understand. When you see the reference scenario, it's the base for a working plan. This is number 1, straight and reference scenario. The second in the process is a doctrine. We put the reference scenario. After that, we build the next level is doctrine. The third level is operational concept. Number 4 is the training. And the last one is readiness and assessment. This all the whole package. And this is now how Israel and NEMA works. We work this all plan, and reference scenario begin the handstones. Okay, after that, why we're here? We speak about climate reference scenario for eruptive emergency. I told you that NEMA deal with eruptive emergency, and that's what I show you now. This is the climate straight map, and this is the eruptive that I will show you. We are facing 4 climate threat. The first one, you see the heat waves. The second is the fire. The number 3 is snow extreme cold. And the last one that we stand here, we speak about flood, storm, and all that, about the flood. For now, I will speak about the process that we will build the flood reference scenario. From now, this will be my lecture. So why we are here? What is the goal of this process, climate reference scenario? First of all, is to set in a flood reference scenario at a national and local level for preparedness and response for government, local, and first responders to the emergency. This is the first one. After that, the next goal is to build in capacities of all ministry and organization to minimizing the damage and the impact on a daily life. This is the second one. This is the goals, and from now I will speak how we do it. To do it, we must have a partners. You see, who is our partners? I will do it short. So the people who are with me on this stage are my partners. We can see near, it's MOT, Yael from Water Authority Hydrologic. We have many from MOG and Itai. And NEMA is the director that took all this group and put them together to one mission. And this is what I think we do this flood reference scenario. And because of that, we get to the end of this case. This is the first one, our partners. The second thing, who are our clients? The clients that we give them the information. First of all, our clients, we supply them tools and information that they can deal with this problem. First one, our client is a planning directors. We understand in a flood and reference scenario, if you don't play properly, we can't build without understand what is the effect and the influence of the reference scenario. This is the first one. The second, we said about a government, ministry, and authority. This is the next level. After that, it's operational force and first response. If we have a case of emergency case, the operation work in the field. And because of that, we must give them this information. And the last one is the local authority. All these storms and the flood reference scenario, it start in the hills, but it finish in a coast area. We have a lot of cities that affected by this flood and the reference scenario. Okay, this is our clients, and from here, I will speak how we built this reference scenario. What is the principle of reference scenario? How we create the reference scenario. Now I will present what are the principles, and we build the reference scenario. We have 8 level, and who do it? Yael, she is the professional of this program, and I do it shortly. First of all, we must know what is our goals and assumption and all that. This is the beginning, the first step. The second, we must analyze the season in when it's happened. We look, if we want to know what will be in the future, we must know what is the past event and return period. After that, we must know for which level we are want to be ready. And this level is 70 level, serve yet a problem. We will not go to the case that it's easy, we go to the 70. The last one is the number 5, sorry. We understand the during and the intensity. During is how long this will be the flood cases. This is number 5. Number 6 is the discharge and flooded area, where the flood affected, which area. After that, we said the analysis, and for region, we see the region that affect by flood, and the last one is flooding in the national level. We must understand the whole package and how it's affect from the level of the country until the level of the local authority. Now I will talk about the region in Israel that are mostly affected by floods in the national level. I showed the map, show us the vulnerable area by floods. And in Israel, we have 3 big areas that we make the analysis for them. First of all is the northern region. We have Gaaton and Kishon. This is the main area that we are dealing with. In the other one is the coastal plain. We have Ayalon and Lachish. This is especially the area that we understand it will be the problem. And the last one is the desert area. We have 3 regions. The first one is the Dead Sea. After that is the Negev and the Arava. And the last one is Elat. We understand Elat have floods too. In my point of view, I born in this area in Elat, and this area this is very close to my heart. This is about the area that we deal with. After that, I want to show you how we do it in a spatial area. Now I will explain the whole reference scenario on one spatial area. Kishon stream in Haifa Bay. We start with the region. The region is Haifa Bay. We see the Haifa Bay area, downtown, and the other Gidor, and the whole region in this area. After that, when we make the analysis, the second step, we said the during. For how long this will be the flood? It's between 2 and 5 days. This is number 2. The second, we see the season is between December to March. Maybe it's earlier, but this is the season. The number 4 is the reference scenario. You can see how many we need to be in this area. You can read there, and we understand after 200 millimeter in one case of rain in a period, we have a problem. After that, this area will be flooded by the rain, and we must be ready for that. And we said the Kishon area, we need 200 millimeter, that we understand this is the area that will be flooded, and we need to deal with this problem, this area. This is the number 4. Why it's so important in the national level? Because we have a lot of infrastructure in this area, and we must understand which infrastructure are influenced by this flood. In this area, we have the Haifa Rainiers. After that, we have gas farm and full pipeline. We have chemical factories. We have train station, and all of you must understand, when you have a flood area, you must find the area that influenced by this, and which manufacturing you have in that area. After this analysis, we do the whole potential in flood area. We take each area and make the same analysis in the area. After we understand the damage and the influence of the flood, it's easier to build resilience, and this is our next mission, to be ready for the storm. And this is the next mission, is my last position. The next mission for us is to understand how we make the plan for this problem. First of all, and that leads us to understand what is the big problem. First of all, government ministry analyze the challenge and contrast response plan. This is the first one. The second is planning and regulation according to the reference scenario. About that, we understand that a reference scenario is a base of planning and regulation in whole level. This is the number 2. We spoke about the whole level, and what we speak now. The reference scenario is based for preparedness and management at all: government, local authorities, operational force, and first responders. And the last one, the Israeli flood. Yael will tell us about the Israeli flood forecasting center, and what I want to tell from here, that is very important center. And he is the official director for distribution, flood forecasting official information to all authority as operational force. We gave them the information, and we understand we have one center that have the all information, and we give it to our clients. Thank you. And now I wish to invite my colleague, Mr. Itai Freeman.
Good evening. This is how it works. Okay. Good evening. I want to take what Geddy's talking and take the concept of reference scenario on the problem we're tackling in the local level. We're talking national level. Now we're talking about the local level. And in general, me and Geddy are the clients. We're getting the information from flood forecasting, and let's see what we do with that. I'm the CEO of the Dead Sea Drainage Authority and the chair of Israeli Drainage Authorities, and I'm going to talk about what is a drainage and river authority in Israel, but we'll do it further on. Israel, relatively a very small country, very diverse country. In a global perspective, the rivers are very small, but very diverse. We have extreme desert in the south. We have Mediterranean climate in the north and in the middle of Israel. And the challenges are different. We have industry infrastructure. We have intense or density of cities and open spaces. We have ecological, religious challenges that rivers are for all of us. And we talked about the river and drainage administration. This map was set in 1996. In every drainage authority sits the municipalities and 3 government entities. Is the Municipal for Environmental Protection, Agriculture, and Health. This is our board. But it's important to understand that in the end of the day, previously we talked about mayors in different sessions. In the end of the day, the mayors are responsible and the mayors are chairs. And this is the work that we do between the national government and the local government. This is part of our challenges. And I want to take you a bit to what is our perspective, what is our challenges. And it's not different in any place in the world. These challenges, sea level rise, sea pollution, increasing in floods, in rain, and frequent flood events. But I want to focus on the 5th one, which I think Gedi talked about that, or Neil talked about, is the acceleration of development in Israel. And sometimes in the center of Israel, not just in the center of Israel, sometimes the intensity of building overshadow climate change factors. We see floods in urban areas in Israel now that we haven't seen in the last 10 years. And now we have to see every year, we see floods in urban area, which wasn't the day before, and it's going to intensify. I want to talk you shortly to a local reference scenario, just in 2 slides to give you, we took the concept of NEMA, we brought the stakeholders together and conduct a pilot reference scenario in 2 regional councils in the east of Israel, and these are our partners. We took all the information we needed, and Gedi talked about what kind of information you need. We set for a table talks exercise from bottom up, from municipalities, school managers, tourist sites managers, first responders. Everybody was sitting there, and we tried to manage together to decide about a scenario that we think it's something we need to focus or to prepare. And in the end of the day, this is the part of the outcome. But what's interesting about that, that was made in 2018. And in the middle of the process, we had a major flood, 3-day flood in April 2018. Unfortunately, 13 people died in this event. It's a big event in Israel. But what we understand that we saw this scenario unfolding in front of our eyes, and we understand that we need to go back to the drawing board and make it more severe. Okay? Just for the municipality and the first responders, it was about 10 days of an event before the event and the event itself, and then recovering people that got lost in the flood. So it was a pretty big event, and we came up with these 3 pillars: infrastructure, population, and economy. And hopefully this concept of a local reference scenario will be adopted by the more municipality, because this is what just a pilot that we try to do that. I want to take you to our daily preparedness. In the east side of Israel, major floods come in spring and autumn. So in September, we sit down with all the stakeholders and gathering together to see in the coming season with the flood forecasting, municipality, major tourist attractions, managers, first responders, and the river authority, and ask what people are bringing to the table. Some people bring tractors, some people bring knowledge, some people bring park rangers that are wandering in the open spaces, and this is our resources. When in the upcoming flood, the Flood Forecasting Center issue a general flood warning. Yael will talk about that. And then as we progress, it focuses on where it will be, how long it will be, how intense it will be, and it gives us the perspective of what to prepare. During an event, the first responders and municipalities do what they do. If there is problems, search and rescue unit, flooding of houses, etc. So this is during the event. Now, the event is not a singular 1 hour, 2 hour, 3 hours. It's a long event. It can be sometimes days. And for us, the most important thing, and that relates to Nir and Yael, is the nowcasting. The nowcasting for us as people in the local level to get information of what is coming really shortly. Very intense rain coming for this area and that area, and we need to prepare. Sometimes we have a very small drainage basins. Sometimes a cloud can be a kilometer south or east, and we have floods in different areas. So the nowcasting, the information that flows ongoing. And the other side of that is the information that we in the field upload to the forecasting center. Said, we have rain, we have floods, we have disaster or whatever we have, and that goes all the way through designated WhatsApp groups. And we have first responders, and we have the forecasters, and we have every stakeholders in this group. So that was really shortly the local perspective for us as a client. And it's important for us to emphasize the effort of the ministry that's sitting here in collaborating the Meteorological Service and the Water Authority together to creating a new entity. And it's new and it's still ongoing, still learning, creating the data, creating the knowledge. And for us, it's very important. As we progress, it will be even much more important. Thank you.
So we had the national emergency authority. We had the perspective of the local authority. Now, how to support this effort? And here comes both the meteorological and the hydrological service to support. So the meteorological service in Israel is under the Ministry of Transport and Road Safety, while the Water Authority is associated Ministry of Energy. So these are two different entities in two different ministries. But flood doesn't know that those are different ministries and this different expertise, because flood is hydrometeorological. You need to know where the rain will and what kind of rain will be, and you need to know what will happen once this rain touches the ground and starts moving or not moving or penetrating, etc. So it was clear to us that we need to work together. We cannot do it alone. And as I said, the issue is here to collect the data, to model it, to issue warnings, and then there is the collaboration with the first responders and the decision making in order to save life and property. Each of those steps demands work together. For instance, we as a meteorological service for years were operational unit. The Water Authority, when they started working with us together, they were regulatory. They were not used to operational work, so we had to bridge the gap. But we didn't know hydrology, and they were the experts. So there was a need to each help the other to overcome the challenges. I will skip this because we are a little bit late on time. Now that we have a joint flood forecasting center, what does the meteorological service does? First of all, the rain monitoring. Okay, so you need the rain monitoring both in real time, okay, to know what's happening, where you have now accumulation of rain and of water. But you need also the historical record, because with the historical record, you can calibrate the hydrological models and do those reference scenario we talked about. Monitoring is not only by stations, monitoring is also by radar that fills in the gap. Very important, especially in the desert, where most of the region is without rain stations, and the radar gives the coverage of the entire region. And as Itai said, once you have such tools, you can do the nowcasting. Nowcasting is a combination of now and forecasting. It is like it seems that's contradictory terms, but not. It's forecasting, but forecasting of what's going to happen in the very near future. And this is critical. Most of the time, if you know that something will happen within an hour, you can do something to prevent casualties. This is an example of a case in Israel. Everybody knows it because it was a flood in the region of Ashdod that also flooded a nearby airport. But what you see on the left is the actual radar. What you see on the right is a simulation of what is to happen within 90 minutes, an hour and a half, and they are for the same time. So on the right you see the forecast, on the left you see what actually happened. So you can see that there's a good correlation between what actually happened and what the nowcasting system provided. For forecasting, you need other tools. The forecasting we are based on today is high-tech computers. So Israel is a cooperating member of ECMWF, the European Center, since 2010. We run our models over there. They run their models. We run models based on their global models. On the left, you can see in this example forecast of the global model, the model of ECMWF for an event. This was an event in which the Kishon, which was mentioned before, got flooded. On the left, you can see the big pixels of the rough model, global model. In the center, you see something different. If you see, those pixels became very small, and the intensities change. On the left, you don't see the red color. The colors here indicate the intensity of rain. And suddenly you see those stripes of red color, which are intense rain. On the right, you can see what happened actually. So on the right is the observation. The two left panels are the forecast. And you see that actually in the observation, indeed, you had this red stripe, and this red stripe coincided exactly with the Kishon Basin, and this was what caused the flood, which wouldn't have happened if the map was like the global model gave. So the local model is fine, it takes the global and make it more refined, more detailed, and allows to run afterwards the hydrological model. This is an example. I will not go deep into it. After you have the nowcasting or forecasting, now you should issue a warning. So we have a system that disseminate warnings to all emergency managers. Each of them get the message through for the region of interest, for the intensity of interest, etc. This is also disseminated to a global system. There is the WMO established a format, a standard of reporting, of issuing warnings. called CAP, Common Alert Protocol, and this file is every platform can run it. So you can open Google or you can open Microsoft and see those warnings inside because they know to read the messages. And I hand over to Yael.
Thank you, Neil. Ready? Okay, so as I was presented before, my name is Yael. I'm from the Israeli Hydrological Service, which is part of the Israel Water Authority, and I'm a surface water hydrologist. And today I came to present the National Flood Forecasting Center of Israel. And we refer to it as the intelligence for disaster management because it really gives information for whoever has to operate in real time. So we're still in the process of establishing the center. And if you look at the timeline before 2018, there were some flood forecasting. They weren't very formal. They were very general. And 2018 was actually a turning point with the Safit tragedy, which we lost 13 lives. 11 of them were teenagers. And following that, in 2019, the decision was made to establish the Forecasting Center by several agencies. So in 2020, it's nice that we had a decision, we didn't have the resources. So we could only partially operate the center. We did the best we could and with what we had. But at the same time, we started looking at other centers in the world, trying to understand how are they built, what models do they use, how do they disseminate their forecasts, and really understand how does the forecasting center need to look and to adapt it to our needs. In 2021, we became already fully operated, meaning we give service 24/7 when there is a rain event. And at the same time, we worked on an establishing work plan that we want to know where we're going and how do we get there. And with the establishment work plan, we managed to get the funding that we needed this past year, and we started recruiting manpower. Just now we're recruiting hydrological forecasters, and by the end of 2024, the forecasting center would look completely different. So the objective of any forecasting center is, of course, to save lives and to minimize the damage for infrastructure and for property by enhancing the disaster management capacity of the national agency by being their intelligence. We do that by disseminating early flood forecasts and warning. We support the civil protection agencies, and in real time, we give updates and warnings according to monitoring. So as Nir presented before, I think the most important thing and unique thing is the very strong collaboration between the hydrological service and the meteorological service. The meteorological service provides us with the rain forecasts. That's their output of their models. We take that output and it serves as an input to our hydrological models, and the output of the hydrological models is the flood forecasting. These are 4 models that we use. 2 of them, the first 2, the EFAS and the flash flood guidance systems, are both or regional or global, and we need to work with these agencies to calibrate them and adapt them to the basins inside Israel. And there are 2 models that we developed in-house, which are the Hydro and the HEC HMS, which are saying then the hydrological forecasters and the meteorological forecasters sit together for a daily synoptic discussion. There they decide what is going to be the forecast for the next few days and how exactly to disseminate it, how will we operate through the entire event. The forecasts and the warnings are disseminated by email, by WhatsApp groups, and the Meteorological Service also has a warning system. We're working on developing a new and maybe more formal disseminating systems with the website. But I must say that the WhatsApp groups are maybe informal, but they're very useful, and we can really get to everyone in the field. We're working specifically with emergency agencies, and every cop and every fireman can get those warnings and forecasts. So this is how our forecast looks like. We give a 5-day forecast with a 6-hour temporal resolution. We divided the country into 4 geographical dissemination zones according to climate and the characteristics of the basins. The warning is in a basin and in a sub-basin scale, and the forecasts are updated every day. To the forecast, we attached maps, and it's very important that the maps are actually impact-based, because the officer in the field does not understand what is 200 cubic meters per second. He needs to understand what is going to flood, where is it going to flood, does he need to evacuate hikers, does he need to block road? So that actually helps us to focus the emergency agencies, where exactly do they have to operate. We also give a map of magnitude and probability, and that's for hydrologists and drainage engineers, which are more professionals. So we don't give only the forecast. As I said, we give also warnings and real-time updates. We look always at our monitoring systems. We have hydrometric stations measuring the flow. We have rain gauges. We have the radar and the rain radar. And according to that, we can really follow the entire event and give updates. So this is an example of a warning and an update. Tonight, heavy rain, it was raining all night, and there's flows, and it's still expected to rise. But what's also is very important, that we get a lot of feedback from the field. These people in the field are our eyes, because we're sitting in a center. And this helps us also to calibrate our models, to understand how accurate are our forecasts, and to give a real update to the entire agencies. So another example that one of the researchers, right, the Taninim stream is full bank, and then we know this is maybe something that we need to send an agency to. So looking ahead, in a flood forecasting aspect, we're working on training the new flood forecasters. We are working on improving our forecast and the impact interpretation, which is one of the most important things to really get to our clients and understand their needs. We're improving our models and developing new models to make sure we are as accurate as we could. And we're developing a dashboard and dissemination platforms. And this is at this part. But we have a really big gap, and that's floods in urban areas. We don't have enough of forecasting tools in these areas. When I talk about floods in urban areas, I can categorize them into 3 classes. The first is the river overflows. The second is the local drainage has a failure in it and cannot get all the water within it. And the third one is the combination of the two. And we need to make sure that we can forecast all 3 scenarios, so we can help the cities to manage their flood events. So we're doing that by mapping the needs of local authorities. It's a very, very, yes, it's a very, it's advertised everywhere, this picture, and it really emphasizes what happens in the cities. And we're working on mapping needs of local authorities and emergency agencies. We're developing tools and models in the urban environment. I think the most important thing we're doing now is defining and building the required database. If we don't have a database, we can't build the right tools. And of course, developing the entire system and assimilating it to the emergency agencies and hopefully in the future also to the public. So thank you very much. I invite Efrat Morin, Professor Efrat Morin.
Okay, good evening. So I will say a few words about how science can help for flood adaptation and prediction. Science of floods is in different directions that I put some images here, starting from understanding the processes that lead to large flood events. We're taking this understanding of processes usually and developing or utilizing models that simulate the floods or predict the floods. We also, as science in general, very much interested on how global warming impact floods, and also science helps to develop tools to transfer prediction into effective decision and policy making. So I would like to give shortly a few examples, mainly on the two central parts. And most of what I will show is from research done by my two former PhD students, Yair Rinat and Moshe Armon. Models are a main tool of our research, flash flood models. This can be process-based models like the central image here, when we simulate the rainfall that transform into runoff and flow over the topography toward the channels and produce these large floods. Or nowadays also there are some data-driven models like machine learning models that also become more and more in use. Any model we choose, it is well known, I think for science for sure, and I think for everyone, that the most important input to these models are the rainfall data. So there's a lot of research looking for what type of rainfall data to use. And in current knowledge, for flash floods, it is understood that corrected radar rainfall is the most appropriate for simulating floods, not only in desert area, everywhere, because it has the appropriate resolution of kilometer and minute scales that can, I don't know if it can be used, it can be represent this small area of the most intense rainfall, these yellow spots that you can see on the right. And actually these are the area of rains that probably produce the floods. So it's really important to represent them in your data. On the other side of the models, another type of very important data is the flood discharge data that helps us to evaluate the model and to calibrate the models. And as you know, flash floods usually would not occur where you have hydrometric stations. And important practice is to go after each flood event and to collect data from the field in order to have data on all these red points you see here, which is the highest data available for the floods, but they are not from hydrometric station. So having the models and the data together, we can better understand how flood events occur and simulate floods. And in this, the case that already been mentioned a few times, this April 2018 event. And here you can see the radar data on the right, a hydrograph on the bottom, and you'll see photos or videos from the event itself. So you'll see a small rain, you'll see a rain cell over the catchment, yes. So this rain cell, heavy rain, it produced slow, okay. Because it's desert area, immediately this rainfall became runoff, but because it was too short, this runoff did not reach the channel and actually did not produce any flood. Only about 1 hour later, another rain cell, we'll see soon on the see it soon. Okay, like 1 hour later, the video is slower in this. So this is now the first rain cell. You have runoff, but you don't have channel. It doesn't reach the channel because it's too short. Okay, now about 1 hour later, another rain cell comes to the catchment. It would produce, again, it produce runoff, and this time it will be long enough and intense enough in order to reach the channel and to produce this very large flood event. So we don't need to wait for everything, but what the message from here is that there is very high sensitivity of the flood, properties to the rainfall properties. So I think maybe you can just skip to this next slide. No, next slide. I can. Okay, thank you. So, so radar data, as I said, radar data is the most appropriate data for flood simulation. However, in terms of lead time, this is the difference between the rainfall and the flood peak discharge. This would be too short. For example, in the event we just saw, it was like 25 minutes lead time between rainfall and flood. This is too short if you think about preparing and warning. So we need to use rainfall nowcasting or forecasting, as already mentioned here. And I think Nir have shown that it's really, the forecasting is now much better, and we have very good data in forecasting. However, it's still, there is still a large uncertainty in the exact location and the time of these main rain cells. So in the bottom, you see the forecasted rain for the same event, and you see this intense yellow rain cell, but it's a little bit to the north of the catchment, and because of that, on the right, you see the simulation of the floods with the real data, with the radar data versus the forecast data. We actually could not forecast any flood just because it was a few kilometers to the north. So this is the main problem. So what we do, we can do what is called ensemble forecasting. We can use many rainfall input. In that case, we just took this forecast and shifted in space in order to produce many inputs. And in this way, we could improve substantially the probability of detection. So the orange color means that we have a reasonable probability of detection by using ensemble forecast. So ensemble forecast is really important for flash flood forecasting. I would now move to the impact of climate change on rainstorms and floods. We try to understand what global warming is expected to, how it's expected to affect the storms, and what will be the impact on floods. What we found out that the most intense storms, and can you apply there is movie there? Oh, no. No, in the same, just go to the image of the storm. Yeah, here, yeah, okay, you can find. So the same storms in present versus future climate, what we found out, the storm will produce much less rainfall. Also, the rainy areas, the areas that is covered by rain, will be lower, substantially lower in the future. However, where you have high rain intensity, they will be much more intense. So this is a contradicting behavior. Less rainfall, less rainy area, more intense. We also found that the number of rainy days will be lower and the rain season will be shorter. So what is the expected effect on floods? And this is, you see, cartoon-like. We have more rain, larger area, but less intense in historical versus future. So we took this data with all the ensemble I explained before, and input to flash flood models. So what we found out is that there are difference between small catchment and large catchment. So over the small catchments, we expect a flash flood to be more intense. We have higher magnitude of flash floods. But as we go to larger and larger catchments, actually, we expect the floods to be lower in general because the effect of the area and the volume. However, as Yael said, this is, in that case, the simulation you see here is for agriculture catchments. If this intense rain would fall over urban areas, we expect to have an increased, and because of the immediate response, we're going to have higher discharge. So in general, we do expect increase in urban flooding, in small catchments, and also in desert, in arid catchment due because of the fast response. So thank you for your attention, and I move.
Good evening. Thank you for staying with us at this time. Good evening. My name is Benny. I work at the Ministry of Agriculture at the Soil Conservation and Drainage Department. I think that you might be asked why a flood is connected with agriculture. It's just because that the Ministry of Agriculture is a regulator of the subject of flood prevention. The plan that I show you today is based on the European Flood Directive from 2007, and the need to do this is this was created because that local solutions to regulation didn't give a good result and stop flooding at Israel. This is what we show today is one thing that we are doing. We're doing a lot of things, but it is only one of them. Why are there damages from floods? There's four good reasons. They're connecting one each other. The first one is that risk and damage are the result of human decisions because the people decided to live near the rivers, near the coast areas. Floods are inventable natural phenomena, part of the water cycle in nature. This means that we cannot stop the rain, we cannot control the rain. We need to deal with it. Therefore, the challenge is expected to increase due to intensive development and climate change. And what that we can do, we can minimize the damage through informed risk management. Small slide about the hydrograph, or what we or how we are as engineers describe this phenomena. How does development affect on the basin hydrology? The graphic description of flow stream is hydrograph. You see it over here. That is hydrograph. The X represents the time. The Y represents the discharge or the flow, and the area under the line is representing the volume. As a change of the development in the basin increase the peak flow and the volume, and this decrease the construction time. That means the flood become much most dangerous, and we have less time to deal with them when they're coming. What are the stages? And now we want to speak about the solution, not about the problem, but the solution. And what are the stages of the risk flood management plan? We decided about four stages. The first one is determines the flood area and the potential damage. And the fourth stage is the response plan. The headlines of the first three stages are focusing, flood map, and damage map. One thing more, the map that you see over here is a map that take from Ireland. They make a very nice work, and we copy them, and it was working for us very, very good. The first thing is, sorry, it's over here, is to choosing the focus area by collecting information from the drainage authorities and local municipality. At this stage, we don't map the damage on open areas, only developed areas like urban and rural areas. And the data is based on past event. This is how we start the work on past event or areas that we know that there's going to be a problem. The next stage, you see over here, it's quite a complicated stage. Sorry, over here. The next stage is a collection of information regarding existing and future and future development, because all of this plant is looking for what's going to be in 2040, 2050. We don't deal with the problem today. We try to deal with the problem that is going to be in 20 years, 30 years from today. This is very expensive stage to collect all this data. And we collect all the data from different level of design plan, as you see over here at the list at the slide. If the change in the cover area in the basin is more than 15%, the planner need to calculate the hydrologic again, because we think that there are going to be big changes in the hydrograph at the future time. After it, we're mapping the risk flood area in 3D model. What you see over here is Hadera Basin. It's the town of Hadera. We're doing it with the HECRAS model. That's the model that we decided to work with because of two reasons. First one is free, and the second thing is because it's updated every time. It's good to use, and everyone is knowing. I want to say that no matter with what model you use, you need to do it right. The mapping process based on three main assumptions. The first one is that all of the planned development area will be carried out. That means everything will be built. And the second thing, it will be built bad. That means all this area contribute 1/100 of the runoff. Why do we do this assumption? Because this is the only way that we can addressing the climate changes indirectly. We don't know what's going to be with the rain, but this is the way that we find to do it. Something very important I want to say, that the model need to be calibrated. Every time that you're doing any model, you need to calibrate, because if you don't do it, you get a GIGO, garbage in, garbage out. After we collect all the data, we are using a damage assessment calculator. We do this calculator. You see over here the land use, and you see the damage of it by shekel, and all the information of land use was grouped damage, because there's a lot of land use. We group them for 15 groups, and to every group we give a damage price, and you just multiply the damage by the area of the land use, and you know which damage will be. We get from this process three results. The first one is the data of the cost of the damage that we can prevent. The second thing is that in which area to focus first. You see the red area, which is great or large damage, and the pink color, that the damage is low. And one of the things that we want to understand is what are the reasonable investment in each basin to preventing flood damage. That means we don't want to put money if you don't need to. After we have this map and we know where the problem is, we need to do the response plan based, and it's based on 4 strategies. The first one is prevention. That means that we are an area that now is not planned for building or construction. We suggest that there will be no development on them. The second strategy is adaptation. That means that in areas that we can choose if to put them building infrastructure or open area, to put the area the third thing is protection. That's meaning in areas like Tel Aviv, Nahariya, Ashdod, every town in Israel which there's river inside, to protect them by regulation of stream, by building runoff regulation reservoirs, especially we mean for engineering measures on this. And the last strategy, it's what that Gedi talked about, when there's event happened, when there's a big flooded, about how to evacuation people, emergency operation, insurance, and like this. The last slide I want to show is area in Nachash Zafim. Nachash Zafim is near Afula. In the area you see the river over here. No, it's not going there. You see over here the river. This one. And you can see over there, you can see a regulated area. And the road that you see over there is controlled on the discharge. They're going along. They're going on the other side of the road. The main thing that we want to see on this plan after it will be finished, a lot of areas like this that we can regulate the floods and do less damages at Israel. Thank you very much. I want to invite Stefan. Thank you.
Good evening. Yes, my name is Stefan Nulenburg. I'm with WMO, and I wonder at this time of the day, what can I still, what can I do to keep your concentration? That's difficult. After more than an hour of very interesting presentations, I really enjoyed it. I'm working with WMO, and what I would like to do in the next 10 minutes or so is presenting the efforts that we do in the field of integrated flood management. Next slide, please. In general, it was back in 2018, before I joined the organization, long before. There was an agreement on the 8 main hydrological ambitions. The members of the WMO, which is the 193 member states, they are represented through hydrometeorological services. Dr. Nir is, for instance, the permanent representative of Israel to us, and they tell us what to do. And these members, they agreed on these hydrological ambitions long term. The first one is no one is surprised by a flood. So all we heard over the last hour is that no one should be surprised by a flood. Second one is everyone should be prepared for a drought. Then it's about food security and science and data. You have to invite me again, Nir. Then I'll speak about the others. Today I will only speak about the no one next. Maybe I come to Israel one day again. So only speaking about no one is surprised by a flood. And what my colleagues did, it's of course you can make long PowerPoints with lots of text. So they made for each of these ambitions is a little graphic. And you see many of the things that were discussed over the last 70 minutes or so were kind of linked to that. It's about better forecasting. Also repeatedly we saw this figure from end to end, from observing the hazard formation with the precipitation and forecasting, and then up to hydrological modeling, to predictions, and to also doing actions on the ground. And so it's a really end to end. And I think the last presentation just was risk mapping and loss and damage assessments before anything happens is going into spatial planning. I think that's all part of that. What WMO, as a small PR, if I may, is also doing is doing a lot of publishing reports that experts from the different countries put together. There's just one came out just now. Letters are too small, but it's for end-to-end assessment guidelines for end-to-end forecasting systems. So it just came out a couple of weeks ago, and you might find that useful. Kind of what are the criteria to assess end-to-end forecasting? And these are kind of the experts from quite a number of countries, and I'm sure Israeli experts could significantly contribute to that. But these type of manuals you find a lot on our websites, and WMO puts that together. And I think Nia said many smart things tonight, but I think one is the best adaptation is collaboration. So what we are facilitating, bringing colleagues from different countries and sectors together to work on these manuals, work on this normative work to support countries. Next, please. So no one should be prepared by a flood, and that was taken up by the UN Secretary General. He, on World Meteorological Day, on March, earlier this year, he said, in 5 years from now, by the end of 2027, everyone around the globe should be protected by an early warning system. Yeah? That was his ambition. And WMO made, UNDR and others also did some analysis. So where is the prediction already? And at least half of the countries do not have a multi-hazard early warning system. And if you look carefully, some countries have, like including my country, but that doesn't mean that it always works or that really everyone from the country is actually protected. So we found out that quite in half of the members where there is a early warning system, it's sometimes less than a third of the population that is actually protected. So there's still a lot of work to do in this field. On the other hand, then, there's I don't know how many studies were showing that investing in forecasting is very good. It pays off. As soon as you have a damage, it's much more costly than all the investments we do before. So I know it's very hard to put up a new center for Yael. I feel with her since years. She said we didn't have a budget. I know, but for Israel, this is cheap in compared what the damage is for big floods. So it would be much wiser. I hope some Minister of Finance is also here today. So it's much wiser to give her more money and Nir and others.
Who's in charge of the budget?
Oh, he is in charge of the budget, then I speak in this direction. No, it's really a good return on investment, and many countries show that. So why the check? Good. Next slide, please. And this is a graph copied from the Global Commission on Adaptation. They looked at when we need to adapt to climate change, what are the best returns on investments? So for every dollar we invest, or every shekel, how much does society get back? What you see here is making your infrastructure more resilient has an average a payback of 1 to 5 or so, roughly. Different studies, of course, it depends. And they were comparing new infrastructure, improving dryland agriculture, protecting mangroves in tropical coastal areas, or water resources management, make that more resilient. And they all have a very positive payback. So every dollar you put in pays back with a factor 4 or 5, something like this. One more click, please. But there was one standing out, and of course I'm a salesman here tonight. So, and the outstanding one is strengthening early warning system. So the average return on investment is 1 to 9, and there's many case studies demonstrating that the return on investment is 1 to 10 or even more. So it's really a safe investment. I know it's very difficult to raise the money for this, but it is important that we communicate these type of results to our decision and policy makers. Yeah. So therefore, the Secretary General is very right to put this initiative out. He tasked WMO to put together an executive action plan. So what do we need? Well, in 5 years, the whole globe should be protected. Also rural areas in Africa. What would be needed? And with very a bit quick and dirty, you might argue, because it's limited time, and you would like to do a detailed study in every country, so there's no time for this. So in 5 years you have to have it. So we put together a big team, put together an executive action plan, and we calculated it costs probably 3 billion. 3.1 billion. And you see here in the disaster risk knowledge and understanding, I think the colleague from soil conservation and drainage, he talked a lot about spatial planning and understanding knowledge about risks. Then the second pillar is on observation and forecasting. I think colleagues tonight explained that, how you do that in Israel. But then it's also about preparedness and response. I think the first speaker from the Ministry of Defense was explaining that very clearly, and others. And also about dissemination communication. I found it so interesting that WhatsApp group are still the most effective, I learned tonight, and it's fascinating, it's good. And but we calculated 500 million for that for the whole world. So it's a lot of money, but in many countries, institutions still need to set up. Communication need to be kind of streamlined, and people need to empower it, and a lot of the hydrological costs are not even in there. So probably it's more in the order of 5 billion or something like this, and nobody knows. And you might say, well, Stefan, you're crazy. Nobody has 5 billion for you. True. And it's certainly not for me anyhow. But that's the global investment that needs to be made. But if you see, only this major flood we had in Western Europe last year was 40 billion. Just one major flood in one country. Only Germany was 34 billion. Only in one country. 200 people died in a country which is probably one of the best prepared, has some of the best hydrologists and the best meteorologists in Germany and Belgium. And so these are countries that are really, compared to many others. Or Hurricane Ida in the US was 70 billion. Just one country, So then 3 billion to protect the whole world is a cheap investment almost, It puts it in perspective. Of course, with this, it doesn't mean that we don't have flood damage anymore. Of course not, I'm not saying that. But if we could reduce it by 5 or 10%, this would be dramatic in terms of only talking about the financial return, not talking about all the tragedies and all the disasters and the personal stories. So I'm not even speaking about that. The Pakistan flood earlier this year was also estimated 40 billion. But a lot of these people in Pakistan, the poor, they don't have a lot of infrastructure value. This is, in terms of the 40 billion, it's more the personal tragedies that are then the problem. Good, this was the global part of my presentation. Next slide, please. And I wanted to just show a little bit of other programs WMO are doing, and that's the Associated Program on Flood Management, APFM. It just recently turned 20. Next. It's a 20 years old program which WMO together with the Global Water Partnership does. I don't want to go through all the small letters, but it's an integrated flood management program. Always the idea to not coming from flood control to more integrated approaches, but we just got a master class this evening about integrated flood management. I think I don't need to explain a lot more on this. Next one. And I think the most interesting one is what I would like to advertise is the help desk. That is basically people in WMO. When they get a request, they try to help countries. So if countries come with a request for assistance in advice or preparing a proposal or feedback on the implementation of things, I think Israel is way ahead. I'm not sure if we can help much. But many other countries come with these very practical questions, and then we provide advice. And every second week or so we get a request. Some of these requests are weeks of work, so it's not just answering an email. But so it is a very helpful thing. And also if you feel this is interesting, we are there to collaborate on that. There's some 30, next slide please, 30 partners who are collaborating on that. You see some of the logos of our partners there. Who it's not WMO having the expertise, so it's kind of through partnership we facilitate responses to the questions. Next one, please. 2 case studies, but given the time of the day, I will go very quickly. First one is in, next please. Is in the Volta Basin, which is a transboundary basin in West Africa. The Volta is mainly known for Ghana, but it comes from Mali, Burkina Faso, but also a bit of Ivory Coast and Benin and Togo are there. So it's six countries. It's 8 million project, and what we are doing there is integrated flood and drought management. Next one, please. I skipped that. Next one, please. And what colleagues are doing, I'm really presenting colleagues' work. I have not been technically involved in this, but it's one of some of my team works on that, and they have they work with Shima, which is from the Italian. It's a public domain early warning system, which is kind of up to top notch of similar systems that I think that Yahel was preparing. So it was set up there, always in collaboration with the 6 countries, and training has been done. Next one, please. And I found most interesting is that it was able to facilitate that 6 countries all share their data. And in some countries, hydrological data is a state secret. Huh? They don't share that. And meteorological data sometimes is easier. Hydrological is often very difficult. But here, they all pool that together, and then you can make more meaningful forecasts and predictions. Next one, and you see through integration of a number of different data sets, static data sets on land use, on topography and all that, with dynamic forecasts from different sources. Next one, we are able to make prediction, and that Volt alarm for Volta is kind of in a pilot stage up and running, and providing real-time, merging real-time forecasts, real-time observations with forecasts and with risk maps that have been produced to kind of guide local people. And the interesting, I believe, is really the transboundary aspect. Okay, and the flash flood guidance system, next one. I just skip that. Just the last point I want to make for today is that WMO also, with its partners and members, we are very much working on this community-based flood management, where it's a lot about discussing with local people. I think the second speaker was making that very clear, that I think you at the local government and how that interacts with national government is critical, but it's also that at the local scale people understand the risk and really find it useful, and we facilitate this process and help as much as we can. Next one, workshops, of course. With this, one more click, I thank you for your, one more click please, thank you for your attention. Yeah.
Thank you to all speakers. I think it's a good time to ask questions, give advice, or any other comments you would like to give.
We want to appreciate people who stay.
Yes, that's of course. Thank you very much for that.
Where's the bus above 9 o'clock?
2 hours ago, I was in a session here in the U.S. Center, and a discussion with some major people from the Senate and governors, and one of them was the chair of Google, I think, in Israel, in Yossi. And they asked him what's the best practice. He said, flood warning system. Google has a flood warning developed in Israel. And they have, Google has a flood management, but it's not in the scale of Israel. It's a world, it's already built it. And they're still using it now for India and Pakistan. So share knowledge.
Efrat, maybe you want to answer that and I'll continue.
It's working. The project of Google, which is, I think, very nice, it's still on river floods, large river floods. It would take time until it would work well with flash.
World-class, river basin, whatever.
Yeah. So, yeah, I think this is certainly something that we would develop also for Israel.
One should remember we have today the global technology giants that know to give forecast for every point and to give it in a very sophisticated and charming way. This is the end product. In order for Google to give a good forecast, it needs the radar, it needs the observation, it needs all the effort that is done, that was described here. This is one thing. The second thing, the fact that Google produces a product, which is great, okay, doesn't mean that now the authorities know what to do, okay? So the process we talked about of getting authorities to understand what is the threat, what is the threat level towards which they should be prepared, what Gedi has said. This is important. This is something that the government should say. To what are you expected to be prepared? This will not come from Google, okay? The budget also will not come from Google. And then, of course, in real time, I can tell you, I work with models all the time, okay? Sometimes they're great, sometimes they are not. You must have quality assurance all the time. The best quality assurance system we have right now is human. Human should be in the process. It cannot be. Maybe in places where you cannot have experts, it's better to have an automatic system. But where you can have experts, it's better for them to see the various models, to see the automated products, and then decide, is it really reliable? What kind of message should we give to emergency services, etc.? The automated service is good, maybe, for places where you cannot find experts.
If I may just add to that, I believe it's fantastic what they do, and of course we should consider it, but it cannot replace the role of government in issuing warnings. So it goes, you didn't suggest that, but somebody could say, oh, well, I found some alerts from some website somewhere, and another website has yet another one, and that completely confuses the public how to react. So I think we at WMO feel that there should be one champion, one lead, and that's the country, that's the National Hydrological or Meteorological Service, and they should issue the warning, and they should decide, and they should lead doing a hazard. Otherwise, it becomes very confusing, and all sorts of other people, which their information is very welcome, but there must be one lead. And I one of the key message for me was this picture where the meteorological and hydrological forecasters, they literally sit together in front of a computer and look, does that make sense? What do we see here? You know, and bring in their expert knowledge and make an assessment, and then inform, and then, I don't know, people need to be evacuated, whatever needs to be done. But I really believe this is a very important thing, and that cannot be replaced by automatic private sector developments. You didn't suggest that. I just wanted to make the statement. Thank you.
Okay. Danny?
The integrated management system which you showed, it makes a lot of sense. I understand in Israel it's new. Is this new only? Is it only in Israel, represented in the Middle East, or is this also a new approach worldwide?
Are you talking about the flood forecasting center?
Yeah.
Do you know any other flood forecasting centers which collaborate between meteorological services and hydrological services?
Probably to some extent they all do, but you know, with varying degree of success, I believe. And in some countries you even have that as the same organization. In a few countries, I need to say, but often it's two different organizations. But this collaboration is absolutely critical. Yeah, that's my experience.
First of all, there are a lot of meteorological services that are hydrometeorological services. That is, you have the hydrologists, meteorologists in the same entities. So all the Eastern Bloc countries are such, and in other places. Where you are together, it's easier to establish. But in big parts, I think, of the world, these are separate entities. And then one of the big challenges is to overcome the ego and the different mentalities of different organizations and work together. I can tell you that for instance, our romance with the hydrological service started at the end of 2018, not because of Tzafit, okay? Because of change of personnel, okay?
I'll just add to that I think it is unique that our forecasters actually sit in the meteorological service forecasting center together with the meteorological service, not only for the daily synoptic discussion. They sit there for the entire event. So there's always exchange of data, there's always updates, and I think that is unique. I'm not sure how many countries have this collaboration of actually sitting together in the same room and working together.
I hope this is, as Stefan said, it's happening all over the world. I can tell in this intimate forum, the thing that we find novel, and I hope we'll be able to talk about it next year, is we started this year to work with our colleagues from the Palestinian Authority and from Jordan. They wanted to come here, but they didn't send the delegation, so they didn't arrive. But this is maybe the very big news for our region. It's a novelty, and we are in a technical stage towards really in the next few days or week, we will start exchange of data between the three forecasting centers, including, by the way, radar data from Amman. They will get our radar, we will get theirs. We already have it with Cyprus, Dr. Kliantis will be here tomorrow and we'll talk about the collaboration with Cyprus. So we already share data with Cyprus, but now it will be also with Jordan and the Palestinian Authority, and I think this is the new road forward.
Yes, please.
Hello, thank you for the nice presentation. My name is Yasha. I am from Sudan, which is an African country. We have the flood problem, which is for a long time. Last year we have like a big area which was flooded, and I think what we miss is the coordination. The parties are doing their own job separately, but there is no any kind of collaboration. So thank you for the presentation and for all the information, and we will try to convince our people to do the same to prevent the people from the damages and the losses they have. Thank you very much.
Thank you.
You said 90% of the population in Israel live in the cities, and you said you don't have data on the cities. So actually, what you said, majority of the people doesn't have a forecast of flood in the cities.
The cities
What
also.
is the forecast of doing that? Closing the gap, the knowledge.
So first, the cities also have streams that cut through them, and if they overflow, they also flood, so we can forecast that. The failures of the drainage system that I think not only us, but also in the world, it's a big gap that I think studies are trying to close. And we do need to invest in that area. So yes, but people are not only in the cities, they hike and they are on the roads, and for that we can give the forecasts. The only problem is the failure of the drainage system, and we're working towards it. That's one of our main goals, and it's really important. We realize that. Miri, you want to come close?
So I thank Yael for the entire work we do together, and to all our colleagues. I thank you for being with us this evening. And now we deserve dinner, right?
Yes,
yeah.
we do.
Okay, you too.